Okay, so let's talk about one of the most fickle things in AutoCAD, in my opinion, when it comes to dynamic blocks, and that is geometric and dimensional constraints. Now, I don't work with constraints on the regular. You can use constraints outside of dynamic blocks just by going into the parametric tab or parametric menu and working with them here. If you don't have any experience with parametric constraints, this may be a little bit new to you. But I don't really work with them very often because they're finicky, and I feel like they're situational. They should only really be used in situations where you have maybe assemblies that you're going to use over and over again, and you want to have those assemblies kind of stay together but be modifiable. And I'll explain what I mean in a second here. I have an example file. So in that instance, they work better in dynamic blocks rather than just outside of blocks in open drafting area where they can, objects can kind of roam freely. So I'll start off by making a simple block. And I don't have any purpose for this other than to show you kind of how the constraints work and how they can mess up. I'm going to create a simple right angle here, and I'm going to block this. I'm just going to call this angle. I'm going to set my base point at the top of this line, and I'm going to select my objects here and just say, okay, my block is created. I'm going to go into the block editor, which gives me access to my dynamic block features. You can't access these before you go into the block editor. You'll see here in the palette that you have access to the geometric constraints and the dimensional constraints. Although it's perfectly fine to use them here, I prefer to use them in the palette just because you can see the names of them easily. Eventually, if you're using them enough, you might memorize the icons, but if not, you're going to find yourself just hovering over this. Also, this palette is going to be here whether or not you have the ribbon open or not with the authoring palettes here. If it gets closed for whatever reason, just click authoring palettes, it'll come back open. And this is where you can access the parameters, actions, sets, and then finally your constraints, as I explained in a previous video. But today we're going to work with constraints. So my goal here is to constrain these two lines together in a way that if I act on one, it affects the other. So here's what I want to do. We'll start with a parameter set. I'm going to do a rotation set because what I want to do is rotate this line right here. So I'm going to choose my selection set, new selection set, select this line. Okay, I only want to select this line, and I want to affect this line as a result without having to have anything specifically attached to it. Yes, I could include it in the selection set, but that's not what I want to do. I don't want to rotate this around this axis. I'm also going to go ahead and change the starting point of this because I want this angle here to line up with this line, the starting point, the grip. So I'm going to change my base angle to 270. That's going to move the grip down to the 270 degree axis, or you know what I mean, axis. So that way it can start at this point, and then we can rotate around. All right, so I've got this now. I know for a fact that this line is going to rotate. I can test that real quick and see that when I move this grip, turn the ortho off, when I move this grip, it's going to rotate this line, okay? So close the test block. Is my ortho on right now? It is. I'm turning it off. Now I'm going to start with my constraints. First thing I want to do is I want to lock these two lines together. I want this corner to always touch this corner. So the way I'm going to do that is by using a coincident. Coincident basically means keep these 2 points together. But coincident will only act on the end, middle, or start, I guess, either the ends or the middle of your object. So I'm going to pick this end and this end, and did it not select it? There we go. Okay, so now there is a coincident geometric constraint on these two lines. Oh, there goes my phone. And what it's going to do is keep these two lines together at this point. So let's go and do a test block. Same rotate command. And so it's got this funky behavior. And this is where it gets kind of finicky because it's doing its job by keeping the point together that I told it to, but it's kind of both moving and somewhat rotating this line with not much rhyme or reason. My only guess is what it's trying to do is if you look at the right side of this line, right here, this line is trying to always point to that. So like, let's say I have this, okay? It's always going to try to point at that circle. So like if I do this, right, and I draw a line here, and I do like a lengthen, it's going right through there, right into the center, basically. So I think that's what it's trying to do. Keep this original point pointing at it, but it's not. I'm not telling it to stretch this line or do anything else, right? I haven't locked that down. All right. Well, what if I do want to lock that down? What if I don't want it to move? Well, I can do that maybe by the same way. Maybe I can add an object here. Let's pretend that this was supposed to be here in the first place as part of my block. What I can do is fix this circle. This circle is now fixed in space. It cannot move. It is locked in place. And it's locked relative to the world coordinate system. And in a block, that coordinate system starts at the origin point of the block. All right, so now what happens if I go and try to move this? Oh, well, before I do that, all I've done is fix this circle. Nothing is happening between these two. I need a way to lock these two together. I can try coincident, and see if that'll work. It's using the center of this circle and then the end of this line. Let's try that and see what happens here. My ortho off, it is off. All right, so it's maintaining that point. Now the line is getting stretched because what I've said is I want you to keep this corner together and that corner together. That's the first rule. And following through the logic chain, this is okay, well, I'll keep this point and I'll keep that point. But you didn't say I had to keep the line a fixed length, so I'm going to stretch it. You also didn't say the line had to stay horizontal. So I'm going to just stretch it around here. Get that out of the way. Clear my notifications here. We get a lot of interruptions today. And so I want to keep this thing horizontal. I want it to just extend. That's my goal here. So what I'm going to do next is I'm going to add a horizontal constraint. That now says we're going to keep this point together, we're going to keep that point together, and we're also going to keep this line horizontal as we stretch this around. So let's test this block again. And now we've got this interesting behavior where the line is locked in place, and it's stopping. At a certain point, it's stopping. And why is it stopping? It's stopping because this line is not extending. And it's not extending because it is my originator. It's my original object. The original object is, well, I can't even say that. It is actually extending. And this kind of, and I'll be honest with you, this kind of goes beyond my knowledge. I don't know the back workings of how AutoCAD determines I'm going to do this and I'm not going to do that when it comes to geometric constraints. And it's not really fully fleshed out in any kind of format. You can look at the help file and it'll tell you like kind of how it works, but it doesn't really say what's the determining factor here. Why does it stretch to a certain point and then stop? And then like now my thing's kind of way over here, and you get this odd behavior where the thing kind of gets disassociated from it. So it is finicky. And you might be asking yourself, well, how does this benefit me? If it's all finicky, why the hell would I use it? If I can't figure out what to do with it. Well, it helps to see an example file of what you can do with it. So I'm going to save my changes here to this. I'm going to open up another file that I have. So I created what's called a gusset plate dynamic block. And since I work in civil structural industry, this is a gusset plate here. It's used at the connection between a beam and a column. Sometimes it's just to a column, sometimes it's just to a beam, but specifically it connects the brace to a column, beam, or both. And this is the gusset plate here. This plate will change in size depending on the angle of the brace, how many bolts are on that brace, basically how big this thing needs to be. There's a few different factors. When I'm making gusset plates, sometimes it takes a while to draw them. So what I wanted to do is have a quick way to make them. So I have kind of a similar situation. I've got some steel. I've got a beam, and I got a column, and here's a gusset plate that would be on. This is a rudimentary one. I made this a while back. I've actually gotten much better with this block, but this is an older version of this block that I happen to have on me. And what this block does is I have a rotate parameter, and as I rotate this gusset plate around, it changes in shape. This was to allow me to change the angle based on the angle of the brace. And you can see as I change it, pieces of it are extending and shortening and changing their angle, which is really fantastic. So I've got certain parts that are fixed and certain parts that are movable. I've also got some extra parameters like allowing me to stretch out. Of course, this one looks, again, this is an older block. I think it has some issues. I had a selection to change the size. I really should get a new copy of this at home, but we'll run with this for now. It's a good example. So let's go to the block editor and see what's going on here. Because the constraints are what's important here, and the constraints are working correctly. So right now the constraints are hidden. So I'll show you kind of generally what's going on here. We've got a rotate parameter. That rotate parameter, if we select it, which is out here, is acting on this distance 1, and it's acting on this distance 2, and it's acting on the objects associated with them, because those are the only things that I want to actually rotate and keep their angle with the rotation parameter. My rotate parameter starts at 45 degrees. And so all this stuff is rotating around. I've got a dynamic constraint, which I haven't gone over yet, but a dynamic constraint basically says this line needs to always stay at 1 inch no matter what. It is fixed at 1 inch. So no matter what happens to everything else, this line will always stay at 1 inch. And then I've got, well, this is kind of an unfinished parameter here that will stretch this portion based on how thick the brace is, yada, yada, yada. Now let's look at the constraints. So we go to the, up here in your menu or your icons, you can say show and hide all. We're just going to say show all, and you can start seeing some of the constraints pop in. And I did put these in manually. You can use auto constraint. I would not use auto constraint. It does a fair enough job trying to figure out what it thinks you want, but in most cases, you have a specific idea of how you want your objects to move, and it's going to be a lot of trial and error. I wouldn't recommend auto constraint. You'll just wind up creating a bunch of constraints you're going to delete. So how do I have these things set up? Well, first and foremost, I want my constraints to all be coincident. So I put a coincident on every one of these. There's a coincident there. There's a coincident here, even if it didn't show up right away. Coincident here and here. I've also got perpendicular, meaning that I want these two lines to be perpendicular. I've also got a vertical constraint. So by making this always vertical, I don't have to put a horizontal constraint on this one, because this will always be perpendicular to this. So as long as this one is vertical, this one will be horizontal because of the perpendicular constraint. I also have a perpendicular constraint here because I always want these two lines to be at an 90-degree angle. However, this line here will change. It will change based on the movement of this line. As this line rotates, this one here is going to change its length and its angle because of the coincident here and because of the perpendicular here. And because this one's horizontal, it will always stay horizontal, and this will just have to stay in place. So as this rotates and moves around, these 2 points will always stay in place, and this line will always be horizontal. We get down to here, I always want this line to be horizontal. I don't have a perpendicular on this one. I have a coincident and a horizontal. I might have tried that perpendicular at one point, and maybe it didn't work for me. Maybe it was messing some things up. So I just chose to do horizontal instead. And then I have a coincident here. Now I've got an extra line. What keeps this all in place is this line right here. It actually has a fix on it. The thing about fix is you cannot move a fix. No matter what you do, you can physically move the block, but within the block, that line cannot be moved. So if I go try to move this line, it's not going to move. Okay, and other things might move and move around, like you can see here. If I take this line and I start moving it, it's going to try to maintain the rules. But notice how that line, this vertical line here, is not moving left and right. That's because of this fix line. What I did is I realized, and I'm gonna start by doing this. I'm gonna delete this fix. Okay, and I'm gonna delete this collinear and this line. This is how I have my whole thing set up, thinking, okay, I'm all good to go. But what happened is, as I realized when I started moving things around, nothing is keeping this in place. I'm gonna close this block. Actually, I'm gonna test this. Okay, and let's see what happens when I rotate this now. You can see that that left line is starting to move, and that is absolutely not the desired behavior. I need that line to stay vertical for this block to work properly. So I thought to myself, how can I make this work? Well, I went through a lot of permutations on this thing, trying to figure out how the hell I was going to get it to work. And my solution was to take a line on top of this one, a short line that overlaps it, fix that line so that it cannot move left or right, and make it kind of short, because that way if it ever gets, it doesn't stick out ever. And then make it collinear. Whenever you have two lines like this, and you put a collinear or collinear, however you want to pronounce it, collinear constraint on them, what it's going to do is put those two lines together. And I believe whichever one, the one that moves is the second one you select. So if I select this first, it's going to bring this line down to here. Now, no matter what happens to this line, that one's always going to be in the same plane. If I rotate it, they rotate together. They can move apart, but if I rotate them, they're going to rotate together. They are in the same plane. That's that collinear. So by fixing it and making it collinear, I'm saying this long line and this short line always have to be matched up. But because they're matched up, because this little one's fixed, and because they're matched up, this line can no longer move. Because it can no longer move, this point no longer moves, and this point no longer moves. So instead what happens is, actually this point can get longer, but it can't move left and right. So because of that, this line can stretch this way, which I think it does in some scenarios. And I may have removed some of the associations a while back, but the whole general idea is that it locks this line into place by using that fix. So you can kind of get an idea for what some of these things do. In fact, I know all of these except for smooth, because I don't really understand it that well, because it works with splines, and I don't deal with splines at all. But it says constrains a spline to be contiguous and maintain G2 continuity with another spline, arc or polyline. That gets a little out of my pay grade. And honestly, if you understand what that kind of constraint does or why you would want to use it, then you probably don't need this tutorial. So, but the rest of them are ones you're likely to use. Coincident keeps 2 points together. Perpendicular keeps two objects together at a 90-degree angle. Parallel will always keep two lines parallel with each other. Tangent will keep a line tangent to a circle. Come on, let's hit the tangent here. No matter what. So even if I were to rotate this, it's always going to be touching that thing tangent, or tangent in some way. Even if it doesn't touch it exactly, if you were to extend that line, it would be tangent. So that's tangent. You have horizontal and vertical, self-explanatory. Collinear, I just explained. Concentric is just basically saying if you have a circle and so you offset one, you can make them concentric by locking them into this. So no matter what, they're going to move together, if it will even let me. There, they move together at all times. So if you act on one circle, the other one gets affected, because even if the size changes, you can make sure that they are always centered together. Again, I'm not going over smooth. Symmetry is just make sure that these two objects are always symmetrical about a line. So if I have maybe like a line and a circle here and a circle here, there's your symmetry. So no matter what, even if I go outward or change it, it's like a mirror command. So that it maintains your symmetry. I'm sure you can see how you can find creative ways to use this. Equal, just make sure that that two objects, lines or polylines, are always equal to each other no matter what. So if you act on one, the other one gets changed. And then fix, you saw here where I'm able to fix a line or an object, any object. I can fix it in space and have other objects use that as an anchor if I need it to be. Real quick, I'll go over dimensional constraints, which are much easier to use. Dimensional constraints, when you're using the generic ones, aligned, horizontal, and vertical, these are almost like using a parameter. Like, why would you want to use a dimensional constraint over a stretch? Because a dimensional constraint, if I put a dimensional constraint on this line, right, and I say horizontal constraint here and here, this dimension here can be stretched. It can only be stretched in one direction. Take it back, two directions. But you only get the grip for one, because the grip over here does not exist as far as the block goes. I mean, you can stretch it in both dimensions within the block, but only one direction outside the block because of the grip. So the other important thing about this is this will show up in your properties menu. So when you, let's say I close this, right? Close lock editor, save changes. I got this line over here. Notice how it can be stretched. And also, if I look in my properties menu, I now have D1. That's that dimensional constraint. I can set this manually to a dimension if I want to. But you can do the same thing with a stretch command. Or not a stretch command, but a stretch parameter. If I come over here and I put a parameter set, just a linear stretch, and I do a new action set on this line. Now I close this out, save it. I got the same grip. I've got the same distance, which, not that one. I guess it was this one. Say I make this like, I don't know, 8. Now it's moving it. Let's make sure I did this right. Yeah, I don't know why it's not moving it where it should. Oh, it's a stretch. I'm a dummy. See? That's what happens when you move a little too fast. Stretch, when you use a stretch parameter, you have to use a stretching window, and I should have known better. All right. Now I can change this to 4, and that maybe stretches it. So in that regard, it works the same. Dimensional constraint works the same as a stretch parameter. There is a big difference, though. The difference is that when you have a dimensional constraint, where are you? In the case of this one, when you're using it with geometric constraints, I can tell it always set this at 1 inch by saying this D2 equals 1 inch. A stretch parameter could not do that. So a dynamic constraint can act as a what do you call it? A linear stretch with one grip. It can act like that. But typically you're using it as a constraint to constrain the length of a line. But the more interesting thing in here is that if I do, let's say I copy this down, okay? And let's say that this is horizontal, okay? That's D1. I can do horizontal here. This probably is going to be D3. Yeah, okay. Same line, right? But let's say that D3 needs to equal D2. You can't, or not D2, which is 1 inch, but D1. You'll notice it just changed automatically because it knows what D2 is. I can also have it do other things. I can say, I believe I can have it do any parameter. Let me put this right. Okay, so it won't let me do that because it's going back to a parameter rather than a constraint. But in this instance, let's say that I have this one going to my properties. Show properties, yes. But this one, I say show properties, no. What you're going to see is that I only have the ability to control D1, not D3. So we're going to test this block. All right. Notice how there's only a grip here. And notice how when I come down here in my properties menu, you only see D1. But because D3 constraint equals D1, anytime that I move this line, or stretch that line, the bottom one's going to stretch with it because they're equal to each other. This can be really handy because they don't even have to be parallel. I know I'm showing them here parallel, but I can have this line, hell, I can have this thing be a circle. And it can be a horizontal constraint. Actually, it's radius. We'll do diameter. Okay, and again I can have diameter. I believe I can have diameter equal d1. Look at that, two different objects. And now I can test this block. By the way, if you ever go to your test block and it's just missing, just double click your middle mouse button or zoom extents, you'll find it. So here I can say D1, and see the properties are shown, but because it's linked to this one, you can't edit it. So I can change this one to 12. And the length of this line changes the diameter of the circle. I can do it dynamically by selecting it, and look at that. How freaking cool is that? Completely different object. It can be located anywhere, but because it's got a dimensional constraint attached to another dimensional constraint, I'm able to control it this way. So dimensional constraints are awesome in that regard because you can, and I can link as many other constraints as I want. I mean, let's go back to this thing and, you know, let's say I got one here and here and here, and we're gonna do a diameter constraint here and here and one more here, right? And they all need to say D1. Oops. Oh, I forgot about that. Man, I completely slipped my mind. I forgot that you can come in here, go to edit this, and I believe just click it. And diameter 3 equals 1, diameter 2 equals 1. Okay, so they're all equal to actually, I want to do this. There we go. So I want them all equal to D1. So we're going to go to test block. Now all of these circles are linked to D1. So as I extend this line, they're all going to dynamically increase or decrease. Now tell me that ain't cool. I mean, I'm sure you can already think of some awesome things that you can do with that. And what's crazy about this is, like, let's go to, well, it's really, I was going to say you can have it affected by a geometric constraint, but you can't. It would be kind of neat if you can have this thing like automatically change based on a geometric constraint, but you can't because it's a dynamic constraint. Sorry, it's a dimensional constraint. So it's going to be whatever the dimension needs to be. But still, the fact that you can tie these things together just makes it really, really powerful. Super cool on that end. In fact, I just realized I do have another one. Let's close this and save it. Here we go. This is a great example of what I was just talking about. I have a connection plate. This is a plate with 8 holes. You'll notice that the first one says it's got a diameter of 13/16 of an inch. But all of the other ones, diameter 2, 3, 4, 5, 6, 7, and 8, they all link to diameter 1, or to hole diameter. And the reason these just say, dia1, dia2 is because they're just generic names, right? And this one, actually, I gave it a name, hole diameter. And the reason it's like that is because when you select this block, did I close the whole thing out? I did. Actually, I just want to test it. Because when I go look at this block and I look at my parameters here, you can see hole diameter is a named parameter. You wouldn't want just D1. It's always a good practice to name anything that's going to show up in the properties menu. Give it a proper name rather than just length 1 and diameter 1 and whatnot, because you'll know what it means at that point. So this plate's got a few cool things. You can change the hole size. So if I want to go from 13/16 to 1 inch, they all go to 1 inch, or 1.5 inches. They'll all do that. Not that I would go that big. I can change this. This is something that's special. It changes the spacing of the interior bolts, and that grip is here as well. This one here controls the separation between the center bolts and the length of the plate, which is an important thing. And this one here controls the outside plate diameter. And then I've got various steel gauge sizes, so it changes the gauge of the bolts. And I believe is that a lookup table? It is a lookup table, which I haven't gone over yet, but this is a lookup table, and you can see the lookup table options. There, as we see them, the gauge, and it puts the actual parameter there, or dimension for the parameter. So there's an example of where you'd use one dimension to control all the other ones in one fell swoop. I don't have to enter the size for 8 separate holes. Just one hole does the trick using linked dimensional constraints. So I didn't get to the rest of these, but you saw me put them in action. You got radius and diameter. I'm using diameter here, and then you've got angular, which just specifies the angle between two lines or objects, I imagine. So, and that's it. That's all there is to constraints. They are finicky. I'm not going to lie to you about that. But the way you put them together in unique ways is kind of really what makes them work. That's the magic. And oh, look, and it turns out I'm going to show you real quick that I do actually have my good gusset plate. This is the finalized gusset plate, and this one actually does work. I'll test it. It's got some different variations of types of plates. This plate here is the one you saw in this picture. Just this one here is just upside down, and you can change the size of whatever the width of the member needs to be. It's got a mirror command, so I can mirror this around on all of these. Again, changing the sizes and all that, and then of course, giving that extra length if I need to, and then being able to rotate it. The only thing I haven't done to this one is put in a limit to the rotate parameter, which wouldn't be a bad idea, so somebody doesn't go too far and try to break it. But it works. I mean, it works pretty good, and it's got all of those constraints in there. Hit and show all. You can see most of the same constraints are still there. And I did want it putting perpendicular in here after all. So, practice, trial and error. I can tell you right now, this block took me about a couple weeks to perfect, just because of all the trial and error between the constraints. Because you put a constraint in and it breaks something else, and you put this and it breaks something else. It takes a while to really figure out how you're going to get all of your constraints working together. But just try one thing at a time and see what you can get to work. You can do some really interesting things. I've come across blocks far more advanced than mine that I'm still learning about, with formulas and all that kind of stuff. So there's so much you can do with dynamic blocks. And once they're done, they can make your life so much easier. So good luck.